Good afternoon. So, this is our first OS lab, and am I audible?
Yes, ma'am.
Yes, ma'am.
So, this lab will be actually divided into two parts. The first part will be familiarization with the Linux operating system as well as a few shell commands. Just a minute. I'm sorry. So, let us begin again. Uh, Two parts will be there. One part will be the shell programming part, where we will be starting with the familiarization with the Linux operating system and a few things about the shell programming. Then, second part will be the process operations, how you can create process and how you can manage process. So that part will come. That part we are going to do using some C programming. So let us start the first part today. For this lab, you have to either install a proper Linux operating system, preferably Ubuntu. And if you cannot install a separate operating system on your machine, get the environment of the Linux operating system. Otherwise, you cannot do the lab. The first part cannot be done. Second part as well cannot be done, even if it is a C programming. But this kind of C program cannot run without having the access privilege to the operating system aspects. Okay, so make sure that you'll be having the environment from next lab. Now, in today's lab, I'll be talking about a few commands that you're going to use in further shell programming that you will be doing on from the next lab. So please get it down. Please note it down, the commands that I will be telling you. And as the lab assessment, as it was done in Java lab, the same thing will be going on. Every day, you need to show us the program codes that you have executed and we will be asking you a few questions. So every day there will be some assessment procedure, and that is a continuous procedure. You all know that what will happen. And the programs you have to submit as in the form of assignment. I will be creating a link for every lab, and you will be creating the document where for every program you need to write the problem statement, then you have to write the code, and the output you can paste from the screenshot. So these three things for all the programs, whichever program you'll be doing here, whichever program you will be given as the home assignment, so you have to
I'm
submit
handwritten
the
code.
document in that. Hmm?
Code handwritten.
Handwritten code, yeah.
Ma'am, why can't we just submit it in Word? Ma'am, it takes a lot of time to write.
At least you will go through. If it is word, then only copy paste thing will be
Ma'am,
going on.
but it takes a lot of time, ma'am. We don't have time to study other things also. We don't get time to study other things.
How do you know how long codes, how much lengthy codes will be there? Do you
Ma'am, in
know?
Java, in OOP, ma'am, there were lots of long codes we have to write.
Do you have idea about the OS coding? No, na.
Uh,
So if it is very lengthy, then only two codes might be you have to write. In those cases, if I feel that it is very lengthy, I will allow you, but not
okay, ma'am.
now.
Okay, ma'am.
Okay? Some of the codes will be only a single line.
Okay, ma'am.
And after that, for today's lab, you need not to do anything. If you have that Ubuntu operating system ready with you, you can practice the commands that I will show you on your machine. Okay. But today, what you will have to submit will be, the first part will be the brief introduction to the Linux operating system, that is layered architecture approach, then multi-user approach, this kind of thing. What we will be discussing here, the little bit you have to write, and after that you will be going to the okay, you will be going to the part of the shell uh, commands, where it should be submitted in form of a 3-column table. The first column is the name of the uh, command. The second column is the description of the command, what the command is intended to do, and the third column will be input. After giving certain input, what type of output you are getting. For this part you can use screenshot. So let us begin. So I was telling about the Unix and Linux operating system. What is Unix operating system? The basic Unix operating system was created in the late 60s in the AT&T Bell Lab, and it is actually a proprietary system which is maintained by a particular company. And the programmers of AT&T Bell Lab, that is in a leadership of Ken Thompson, they developed the Unix operating system. And first they started with all the programming language those were available at that time, like the basic and B. Afterwards they thought that with those kind of programming language it cannot be possible to write a proper operating system like Unix. So they first developed they developed the programming language C, and then using C they developed the Unix operating system. So initially, Unix was completely based on command line environment, a black screen on which some white lines were coming. You have to give command and it will provide you the output. Obviously, it was not attractive to the normal naive users, and it is very difficult to give a command in a particular format when the machine is not used by a computer programmer. So, to get rid of that problem and to compete with then famous Windows operating system, further development was done on GUI, and now Unix is following the GUI also. The basic advantage of Unix operating system was on the security. It was very secured and so far it was very famous in companies and different universities for their project purposes. Furthermore, in early 90s in Helsinki, the Linux operating system was developed, which is actually called the clone of Unix operating system. It completely followed the entire technology that is followed in Unix, and so far it is called the clone of Unix. The kernel system of Linux is actually identical with that of the Unix. What is the difference? The basic difference is Linux is open sourced. So anybody can contribute to the code of the Linux operating system. And its look and feel and etc. Everything was compatible with then available operating systems. So if you talk about the difference between Linux and Unix operating system, obviously Linux is open source. The source code is available to the general public. So anybody can contribute there. And if there is a bug, it can be easily fixed by the contribution from all over the world. So if Linux has got a bug, it can be fixed very easily within very less amount of time. But if Unix is having a bug, that will be fixed only by the particular company who is maintaining the Unix operating system. So the user needs to wait. Now, the Linux operating system, the basic default shell is bash, and in Unix operating system the default shell is the Bourne shell. Now after that we can say Linux threat detection, so I already have discussed about it. And apart from that, the different type of Linux could be Red Hat, Ubuntu, then Solaris. So these are famous Linux operating systems. And similarly, different Unix operating systems are also available like HP UX, AIS, BSD, etc. We will be concentrating on Linux operating system as we will be working on Ubuntu. All the demonstration will be done on Ubuntu.
I have CentOS installed in my computer, so I can use it, right?
Yeah, no
Okay.
problem. If somebody is having Fedora, somebody is having Red Hat, no problem. All are Linux.
Yes,
But
ma'am.
maybe a different default shell you may have. Okay. So in that case, a little bit of change in look and feel of the command output. That is not a major thing. You can use. Now, the basic feature of Linux operating system is it is a multi-user operating system and it works on the client-server architecture. So there will be multiple clients that can attach to the server. If you go to our lab, in our lab also there will be a Linux server which is attached to a number of clients. Clients are self-sufficient. They are having the computation power. Still, for certain type of services they are dependent on the server, like the DBMS. In the DBMS lab you'll be sharing the DBMS server, the database server from a specific server. The service will be available from the server itself, and you will be given with the client machines which are executing the program with the help of the server. Okay, so this kind of architecture is available in Linux operating system. Linux works in multi-user operating system as well. So at the inner core, there will be the hardware over which the software, the system software or the operating system will be there. So hardware on which the operating system, on which the system software and application software. And users are interacting with the last layer. Now, this OS, if we are talking about the Linux or Unix operating system, it is having two layers in it. The internal layer we call the kernel, and the external layer we call it the shell. As it is following the layered architecture, so it becomes very easy to maintain the proper security for the inner core of the operating system. Somebody cannot directly interact with the kernel without passing the layer shell. So that obviously enhances the security of the operating system itself. And the purpose of the shell is basically working as an interpreter. Interpreter means when the application program will be generated, suppose there are the users who are trying to process commands. So the commands will be first given to the shell. Inside the shell, the commands interpretations are written. So the commands will be interpreted in the shell, and after that, that interpretation will be going to the kernel for execution. Okay, so not directly any command can hurt the kernel. Kernel cannot understand a command directly. Inside the shell, there are few programs written, which are basically the service routine kind of a thing. So whenever a command is coming, what the command will do, that program is present inside the shell. Those subroutines are written in C language. As the entire operating system is designed in C language, so those subroutines are also designed in C language. So whichever uh, command you are trying to execute, that is exactly executing a C code. You can also write your own command. You can create your own user-defined command, and you can incorporate that command to the shell. Okay. So furthermore, whenever anybody wants to execute the command you have written, it can be done. It can be identified as a predefined or user-defined command. So that can be done. Only what you have to do, you have to contribute your code to the shell. You have to incorporate your code to the shell. And as we know, Linux is a contributed operating system. Anybody can contribute. Shell commands that we are talking about can be largely of two types: internal command and external command. Apart from the internal and external command, there may be user defined commands as well. The internal commands, those are pre-coded in the shell. We also call it shell built-in. Shell built-in. Okay. These are the interpretation of the internal commands are actually the part of the shell. The shell code is also incorporating them. Okay. This can work very fast. Why? Because they are internal to the shell. Shell can very easily find out what are the subroutine that it has to follow to execute a particular internal command. So they are very fast. Apart from the internal commands, some more commands are further contributed to the Linux operating system by some people. Okay, those are coming in the category of the external commands. The interpretation of the external commands, the C programming that is related with the external commands, those are kept inside the folder bin. Now, when we are talking about these folders, the Linux operating system, the hard disk or the memory which is linked with the file system which is linked with the Linux operating system starts with a root. This slash we call it a root. Okay. In Windows we have different drives. The partitions are known as drives like C drive, D drive. In that way different drives are first created, and under the drives the folders and files we are keeping. But in the Linux operating system, we have a file structure which is headed by this root. Under the root, there are predefined directories like user, like bin, like mnt, like home, etc., etc., etc. So these are all predefined. When you'll be loading the Ubuntu operating system, you'll be getting this file system pre-created. Okay. So this user bin, mnt, etc., these folders are basically the part of the operating systems, and the operating system's own files are written inside it. Under this home, if you have say 3 users users in a particular system. So for every user, under the name of every user, folders will be created. Say user 1 is the name of the first user, user 2 is the name of the second user, user 3 is the name of the third user. Suppose you are the user 1 and you have logged in with the privilege of user 1. So your territory will be confined up to this. Okay, you cannot go beyond this level. You cannot go to the siblings, you cannot go to the parent, because you are user 1, you are a normal user, so you have to be confined inside this particular directory. Here you can create your own structure, you can create a number of folders, a number of files, whatever you want, but you have to be confined here. Your permission is only within this particular directory. So this structure is enhancing the security of each and every user. User 1 cannot manipulate or cannot change anything in user 2 or user 3 or to the other folders which is present in the operating systems portion unless it is having the permission. If the permission is given, it can do that. If the permission is not given, it cannot do any changes in the other territory. Okay. Now, if you have logged in as a root user or the super user, SU privilege, okay. So if you have logged into this super user privilege, your territory starts right away at this root. Anything and everything you can alter because you are the super user. Okay, but the normal users are only confined within his or her own directory, not beyond that. So this root bin is basically this directory. Here the coding that are incorporated afterwards as the command, these things are written. Okay, when you'll be loading the Linux operating system, along with all this user MNT, the bin also will come. Okay, and these are external commands, but these are also taken as a part of the operating system, not as shell built in, not as shell's internal command, but as an amendment to the system. Okay, so external commands are the amendment to the system, like plugins. So these are slower than shell built-in. Shell built-in are faster because they are readily available. External commands are a bit slower because they are not present in shell. They need to be loaded and then they have to be executed. So they are little bit slower. Apart from this internal and external commands, those are readily available at the time of loading the operating system. We have a third category as well, that is the user defined commands. User defined commands are specific user, they can write a command, they can use it in the local machine. Okay, in which machine you have created it, you can use it in the local machine as a command if you can set the privilege properly. We will be doing some lab assignment on this also, but these are not external commands. If you want to make it external command, you have to communicate. You have to communicate with the Linux um, Linux group, which will be incorporating your command if they think that your command is capable of holding inside the Linux operating system, so they can incorporate it in the external command. Otherwise, in the local machine, the user-defined commands are also available. Now, how the commands executes? When you issue a command, first it is searched inside the shell built-in. If it is found in the shell built-in, it will be executed. If it is not found, it will next check it in the root bin. That is as an external command. If it is found in the external command, then that will be executed. If not found, then it will check for the environment variables under which if somebody has incorporated any of the user defined commands or not. If found, that will be executed. If not, then it will report command not found. So these are the four stages of execution of a shell command. Now, types of shell command. Shell commands can be of two types. One is the normal command, another is the filter. Normal command means which alters the original content on which it works. Every command works on a particular input. So if the input is getting modified after the command's execution, then we call it is the normal shell commands. But if after execution of the command, the source data is not modified, only the output is shown on the screen, but the source data is not modified, then we call it filters. The shell command that we will issue, we will first open a command prompt. There we will be finding a prompt. Either it will be a dollar or it can be hash. If it is hash, that means this user is having a root privilege. If it is dollar, that means it is a normal user. The normal user, then after what you write, it is the command's name. Okay. After the command name, you may have to incorporate some options, like those will come after this hyphen sign. After the hyphen sign, a number of letters you can incorporate. Those are called the options. And also, you can incorporate some parameters according to your choice. For example, cat is a command, gcc is a command. Here abc is the parameter, abc.c is a parameter, gcc abc.c is parameter minus lm or hyphen lm is option. This is parameter, this is option, this is again parameter. So different commands can be assembled with parameters and options as per the requirement. Now here comes a number of commands that we are going to show you here what the command does. Okay, so these commands we are going to execute. Note it down, note the name, note the what the command is doing, and when you will be issuing the command on your machine, they will provide you some kind of output. You can put that thing on the third column. Okay. Just wait a minute. I'm sharing the Linux system with you. Okay. So here I start my terminal. You can see I am having here this dollar prompt. This means that I am using a normal user which is not having any super user privilege. Now, here if I write pwd, that stands for present working directory. So it is basically showing the entire path in which location in the file system I am presently located. So where I am inside this root, then in home. Under that, Shatarupa is the name of the folder that has been created under the username of this user. Under that username, I am presently inside this desktop folder. Okay, so this is the present location that I can get using this pwd. Now let us start with the date command. Let us start with the date command. So if you issue a date command, what you can get, it is showing the entire date and time details of this particular system clock. Okay, now from this date, if you want to get a particular data, like if I write date plus percentage d, it is giving 5. That 5 means the day, the date, today's date is 5. But instead of small d, if I put capital D, it is giving me the date in a particular format. Then if I write age, that is the month's name. But if I give small m, that is the month in number. Then if I write here capital M, that will be the minute. If I write here capital H, so this is the hour. 14 is the hour. Then small y is the last 2 digit of the year. Putting capital Y, the 4 digit year. Putting small a, Tuesday, Q, the format is 3 letter. Tuesday, the full thing you will be getting using capital A. So these are the few of the options that I can adapt with the date command. Now, if you want to elaborate on any particular command, then you can use man. Man stands for manual. Okay, manual to the Linux operating system. Man space the name of the command, and you are into the manual. Okay, here you are getting the list of all options. Those can be added with this particular command. And here is the format controls. Okay, what means what? Writing what, you will be getting what. So this entire listing you are going to get from here. Okay, so colon Q to come out. This is the VI editor. So you must be having idea about the VI editor and gedit. So VI editor is the default editor for any Linux file, and gedit is a add-on editor that we are having in the Linux. Okay, so date is this. After that, cal stands for the calendar, which shows the calendar of the present month. But if you want the whole calendar of 2021, then you have to provide the year. After the cal, as an argument, you have to provide the year. If you want to get the calendar of May of 2021, so you just provide the data like this. Okay, so in this way, if I write so, here you can see this is a interesting thing. In 1752, from lunar calendar to the solar calendar, the transition was done in the month of September. So you can see after date 2, directly we are coming to date 14. Between this, there is a discontinuation. So these kind of things you can check. Any year's calendar, any month's calendar, you can get out of like. Now, the next thing will be ls. The meaning of the ls is listing of the files and the directories. In Linux operating system, all directories are also treated like files. So they will be always treated in the same way. Only the difference is the directory is a collection of links towards the uh, subdirectory and files. It is combining all those links together to form the directory, and files are normal data files. Okay. Now all the blue entries you can see here, these all are the directories, and all white entries that you can see here, these are the files. So this is the listing of the files and directories present inside the present working directory. Okay. Now one more thing, the extension, giving an extension after a file name is not mandatory for the Linux or Unix operating system. But you may see that C programming or Java programming demands to save the source code with .c or .java extension. Why so? It is a mandate from the compiler side, not from the operating system side. Operating system do not say that you need to provide a extension. So extension is not at all mandatory for the operating system. It is the requirement of the particular compiler you're using. Now, ls also comes with a number of variations, like ls minus l. It is the long listing. Long listing means apart from the names of the files and directories, we are having many more components related to that particular file or directory in this tabular formation. The first field that you can see here, this is called the permission mode. The second field, it is the number of files or links associated to this particular file or directory. Then is the creator or owner of the file. Which user is the owner of the file? Then is the group of the user. User belongs to certain group, so that group's name. After that, this is the size of the file. Then it comes to the last modification time or the creation time of the file, date and time of creation, or if the file has been modified, then the date and time of the last modification is shown over here, and finally the name. Okay, so every field has got certain importance. Certain importance. So this is, if I take the example of this one, so this is basically starting with D. The very first letter that is present in this permission field is indicating the type of the file. D means it is a directory. You can see all the blue entries are starting with D. These are the all directories. And which are starting with hyphen, these are the normal files. Apart from this D or hyphen, we may have C or B, which is indicating different kinds of device drivers. If B is written here, that means it is a device driver, which is a byte-oriented device, and C means it is a device driver, which is a character-oriented device. Okay, so the first letter present in the permission field is indicating the type of the file. After that, 9 more fields are there, which is indicating the permission mode regarding this particular file. Now for that, I need to elaborate it here. By the way, I think these things are known to you, na, permission mode and all.
No, ma'am.
Okay, so, okay, no problem. So I told you there are 10 fields. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the first field is the type of the file, and type of the file can have the options like D, B, C, hyphen. D means directory, hyphen means ordinary file, B and C, depending on the type of the device drivers. So this is the first field. What about the rest of the other fields? There are 3 different kinds of the users. First is the owner. Second is the group. Group means there are several groups. Each of the user is belonging to certain group. Even if the group is containing only that user, that also may happen. That is happening for my example. I am the only person in that group. Okay. So the group name is also Shatrupa. So owner, then the group in which owner is belonging, and the other users. Okay. Who are not part of the group. So owners are known as user as well. Owner, group, and other. And there can be three different kind of accesses: read, write, and execute. Okay, read stands for R, write stands for W, execute stands for X. So owner can have three different privileges: read, write, and execute. Group can have three privileges: read, write, and execute. Other can have three privileges: read, write, and execute. So if you sum them up, how many letters you're getting? 9. So these 9 letters are basically the permissions. The first 3 permission is for the owner. The second 3 set will belong to the group. And the last 3 are belonging to the others. Now suppose the owner has got all the privileges. So it will be shown like read, write, execute. The group is having read and write, but the execution permission is not given, so it will be shown like hyphen. The other users are having only read operation, and write and execute is not given. So those will be hyphens. So those permission which is not given is shown as hyphen. Those permission which is given, so it will be showing as a corresponding character. Okay. So in this way, if the permission mode is shown, that means the owner has got all permission, group has got read and write permission, others are only getting the read permission. Now these permissions you can change also. For that purpose, the ch mode is the command which can change the permission of a particular file. Suppose your file name is ABC, and suppose the ABC file name is having this kind of a privilege. Now, you want to revoke the write permission from the group. So what you can say? You can write chmod group means G. Owner or user is identified with the letter U. Group is identified with the letter G.
मैम
And
आपका स्क्रीन
other
विजिबल नहीं है.
invisible नहीं है.
है
Oh,
तो.
sorry. Sorry. So suppose, okay, I was telling about the owner is U, group is G, and other is identified by O. Don't take that O means the owner, O is the other. Owner is U, owner or user is U. Okay. Now suppose the file ABC has got the permission like this: read, write, execute for owner, read, write, execution permission is not given to the group, and read, after that write and execute is not given to the other. So in that case, if you want to revoke the write permission from the group, so what you have to write? Chmod, the chmod I am describing here. Okay, chmod, then group minus W from ABC. So this permission will be changed like RWX R dash dash R dash dash. This will be the changed value of the permission mode. Now suppose you want to grant write permission to the others or execute permission to the others. So what you have to write? Chmod other plus execute on ABC. So ABC permission will change like RWX, R dash dash, R dash X. Now, if we want to do these two things together, how can you do that? Basically, if the permission is given, then it can be represented by 1. If the permission is not given, it can be represented by 0. In that way, if we try to encode this permission mode, what we'll be getting? 1, 1, 1, 1, 1, 0, 1, 0, 0. So, in octal formation, what is this number? In octal form, what is this number? 111 means 7. 110 is 6. 100 is 4. So, this permission mode is basically encoded as 764. And as an output, you are trying to get this permission mode. This permission mode, if I encode, so it will be 111, 100, 101. So, what is the corresponding octal? What is the corresponding octal of this? Can't you find the number? What is 111?
Ma'am, 7.
After that?
4.
4.
And last one?
5.
Okay. So you can write CH mode 745 on ABC. So from this, it will be changed to this. So in this way, if you want to grant all permission to all the users, what you have to write? What will be the code for the permission mode? All permissions are granted to all the users. What should be the code?
Ma'am, 777.
Exactly so. So if you write chmod 777 ABC, so all permissions will be granted to all the users. So let me take this file 1. File 1's permission mode is -rw -rw -r. If you want to give all the permission to file 1, then we can write chmod 777 to file 1. Now, if I write ls minus l, so all the permissions are given to all the users. So that is what we can do. So this is how we can change the permission mode. After that, the next is the total number of subfolders or links that are created under it. If it is a normal file, there will be just one. Only one file is linked with it. It is a normal file, ordinary file. But if it is a directory, then minimum 2 you will be finding over here. Now, if I try to enter this C drive, so what C folder. So what I have to do, CD, that stands for the change folder. CDC. So using the prompt, you can see that I am inside the C folder. Now if I write ls minus l, so there are lots of files present, files and folders. To be more specific, let me write only ls. So 2 folders you can see over here. One is ch demo problem, another is test. But the link was showing it is connected with 4 folders. How? Now there is another option. We can relate with the ls minus a. You can see this was ls output and this is ls minus a output. So if you compare between them, instead of 2 folders, you can see 4 subfolders here. This dot and double dot, these are 2 hidden folders. These means the present directory and the parent directory. Okay, these are 2 hidden folders. Anytime you will create a folder in Linux, these 2 folders are by default given. So you can see in this long listing, all the folders minimum will have 2 links. These are this double dot and dot. Okay, and apart from this dot and double dot, if you have created some more folders, so it will be shown that, so it will be adding up the number of subfolders with this 2. Okay, so minus a basically is for showing the hidden files. In Linux operating system, the hidden files start with dot. Any file name that starts with dot means it is a hidden file. If you want to show the hidden file on the listing, you have to use this ls minus a. Now, if you want to have the long listing of all hidden files as well, so you have to combine the 2 options, ls minus l and ls minus a together, and that will become ls minus la or ls minus al. So the order doesn't matter. Here you can see these are the normal ordinary files and the hidden files are also listed here. Okay. So you can see in the parent folder, there were 9 directories. In the present folder, there are 4 links, 4 directories. Single dot means the present directory, double dot means the parent directory. Now CD, using CD, you can get inside another folder. Using CD space double dot, you can get 1 folder back, 1 step back. Okay. So earlier you were inside the C folder. Now you have come 1 step back. How to create a directory? To create a directory, mkdir is the command. Make directory. Then you have to provide the name of the directory that you are trying to create. Suppose I am trying to create the directory ABC. Okay, now you give ls. You can see the ABC folder has been created. If you want to get into it, so cd ABC, as I have described previously, cd for the change directory. Now, suppose inside this ABC, we are going to make a hierarchy of the directories. Like we are inside the ABC. Inside ABC, I'm going to create A. Under it, B and C. Under this B, I'm going to create D and E, and under DF. So what we can do, we can stepwise create the directory, get into it, again create a few directories which are coming inside it. In that way, several make directory and CDs we can do. Or else, what we can do, I'm showing you. The entire directory structure we can create at once. So for that, you have to write mkdir. So the entire tree, when you are creating, you have to start with the root. The root is A. After that, inside A, 2 directories are needed to be created. So first you need to create the roots and all. Under B, you have 2 more directories, D and so now if I test with ls, inside ABC I have A. I'm going inside A. B and C has been created. Going into B. D and E has been created. Going into D. F has been created. So entire directory structure has been created just by using a single mkdir. Okay, but always the root should be created first, and then the leaf level you can go. If you do not process it accordingly, then there will be a problem. So this AB can come after AC also. AC can come before AB also, but AB cannot come after ABD, because ABD is a subdirectory under AB. So ABD should come after AB on itself. Okay. So the directory structure we have created like this. Now to remove a directory, we will be using RMDIR. But before going to this, CD dot dot. This way we go one step back. But if we wish to go to my root privilege, then I should write CD backslash twice. Now you can check with PWD, where am I? I am in the home, in the Shatarupa folder, that is my user folder, up to which I have the privilege. So I am directly from desktop, ABC, A, B, D, everything I have skipped directly to the base folder. If you have the root privilege, you can come back to the root folder directly. But I have the privilege from the Shatarupa folder, so I have come back here. Now, again, I am going back to my ABC folder. So directly, how can I go? CD, inside Shatarupa, there will be desktop. Inside that, there will be ABC, and I'm directly inside ABC. So that is also could be done. After CD, if you give a path, you can directly move into that. Okay. Now, I am inside this ABC folder and I want to delete all the folders which are available in the tree structure. So let me go inside. Let me show you how to delete one directory. So after this, I had A, then B, then D, then F. Okay. Now, if I try to only delete the F folder, so I have to move backward, and if the F folder is empty, I can delete it with RMDIR, that stands for remove directory, then the name of the directory, and now you test with ls, there is nothing. That means the F directory has been removed. But if you want to delete the entire tree structure at once, as you have created them, so that also is possible. Only the so I'm in the desktop. I want to delete everything like ABC inside A, then inside B and C, then inside B there will be E and D and E. So all these folders I'm going to delete with a single RMDIR. So if the folder is empty, you can delete it. So the first empty folder I'm going to get here is ABC, A, B, D. Sorry, D. And also ABC, A, B, E. So if these two folders are gone, then B folder also will be vacant. So ABC, A, B I can delete, and ABC, A, C also I can delete. This ABC, A, C can come to the previous locations also, because that folder was previously empty. After that, my A folder is also empty, so I can write here ABC, A, and then after ABC folder is empty, so ABC should also be removed. Okay. Now you check with ls, nothing is there like ABC. Okay. So this is how RMDIR works. The next command we will be discussing is who. Who means it should give the entire list of all users along with their terminal name, terminal ID, sorry, and the date and time of their first login and on which terminal they have logged in, every information regarding that particular user, how many users are at that time linked with that particular server. In this server, I am the sole user who is linked here, and I am working in the terminal 0. So it is, and this is the time of my login. So all this information, last login actually. So all these informations are being shown here with this who. If you can find in the lab, you will be able to see that other users are also working in different terminals. So that list also you can find. Who am I? From this list, who am I? Who is this user on which you are working? So it will show you the name of the user. Who are you? On which user you are working presently. Okay. So date cal who am I, ls mkdir cd cd backslash pwd, all and ch mode we have done. Vi editor, so you all already know. Rmdir also we have completed. Now we are going to the more important files. Before going to this, let me delete the files. Okay. So here cat command. Cat stands for concatenation. Concatenation you must be knowing. Concatenation is how two contents are amalgamated together to form a single content. So cat command is basically coming from concatenation. Now using the cat command, you can create a file. So for that purpose, what you have to do, cat, then this greater than sign, we call it the redirectional operator. And after that we need to give a file name, say file1. Then it will, the cursor will move to the next line. I'm writing the content of the file. Okay, so after completion of the last statement, you press and enter, go to the next line, then you press Ctrl Z. If you press Ctrl Z on the last line will not be considered. Okay, so this is how we create a file. Now if you do ls, you can see the file1 has been created. Now if you want to check the content of the file, that also you can do the same command, writing cat. Don't give redirectional operator. Redirectional operator is used for creation of a new file. If the file is pre-existing, it will remove the content and it will rewrite the file. So redirectional operator is basically the file creator. But to check the content of the file, you can write cat, then file name. So it is showing you the file. Similarly, let me create another file again. Cat redirectional operator file2. And I'm writing here I am fine. Going to the next line, Control Z, it will stop it. Now check the content of file2 also. So I am fine is the content of the file2. Now it comes to the actual utility of the concatenation. Cat file1 file2. So it is concatenating the two files content together. Now which file it has modified? On which file the concatenated output is going? To check it, let us check the file1. No, the file1 is not modified. Let us check the file2. File2 is also not modified. So the conclusion is cat has concatenated the content of the file, but it has only shown it on the output window. It has not changed any input data. So can we call cat as a filter, according to the definition of a filter, filter was not changing any input file. So it is doing that. So we can call cat as a filter. Now, if we would like to save the content of this concatenated output, what we have to do? This cat file1, file2, after that put a redirectional operator, and let me give another file name, file3. Now check the content of file3. You can see the concatenated output is being saved inside the file3. So if we want to get the concatenated output inside the file1, what should we write? Can you suggest anything? If we want to have the concatenated output inside the first file, what we should write?
Ma'am, cat file 1, file 2, directional operator file 1.
If we do so, there will be a problem. That is because the redirectional operator is having a highest precedence. It starts before the other operation starts. If you think about the left to right, so it should execute the cat first, after that the redirectional operator should execute, but actually that will not happen. The redirectional operator will start first and it will create the file. After that, the cat command will execute and the output will be moving into the file that has been created by the redirectional operator. Now, if you put file1 as a file name that is to be created, then what the redirection operator does, if it is pre-existing, that file is going to be deleted and it will be created afresh. So the content of file1 is going to be removed and then the file1 will be ready. After that, when you will be calling this cat file1 and file2, in file1 you don't have anything. So only the content is available in file2. So after concatenation, the output will be the content of the file2. So you'll be getting file2 content inside file1. So let me check it. See, the content of file2 is coming to file1. So when you'll be doing the shell programming, make sure that in such a type of situation, do not give such a file name which will be used as input further. Okay, after the redirectional operator, do not put a file name which will be used as an input further, whose content you want afterwards. You cannot give it after the redirectional operator because that content is going to be removed first, and after that the cat or anything you have written, that will be executed. Okay, so this is the cat function. Now echo and okay, echo and WC redirection operator we have already discussed. Okay, let me go to the echo. Echo is a very common kind of command which is basically used for printing something on the console. So if I write echo hello world, and between the hello and world I'm putting a number of spaces and I'm giving the entire thing within double quotes. So you can see how I have written it there, exactly the same thing has come on the output. But without double quotes, if you give the same thing, the extra spaces will be truncated, terminated. Okay, so this is what echo. Now by default, after echo, a default slash n is given. But if you don't want to put the slash in, then what you have to do, you have to write echo minus n. So you can see after printing the echo output, it is not coming to the next line. Exactly on the same location, the output, the next prompt is coming. So this is how you can get rid of the default /n after the echo. After that, read. Say I'm writing read X. Now it is stopping to get some data. This is to take input. And if you want to check whether the X has been given with 12 or not, so that you can echo, you want to echo the value of X. So for that purpose, you will give $X. Okay. So 12 is given in X. Now, shell is a weakly typed language. That means the data type declaration is not required. The data is used and it will take the shape of in which the data was modified. Here I have given the value 12. So X is basically becoming an integer. But if I have given ABCDE, then it will be taking the shape of a string. So it is weakly typed language. It takes the data takes the shape of the initial value as for it was used with. Okay, you need not to declare the data anywhere. So this is the read and echo. After that, WC command. So the content of our file 3 is this. WC command is basically the word count. If I write WC file 3, it will give me there are 3 number of lines, 8 words and 34 characters in file 3. If you count the number of characters, you will be getting only 33 characters. Where is the 34th character? It is the end of file. The EOF is also counted as the last character. Okay. Now, separately, you can choose any one or two of this word numbered, line number, and character numbers as to give the output. So, if I write here WC minus L file 1, so it will show total 3 files are there, 3 lines are there. Only the line numbers it is showing. If I write WC minus W, it will show how many words are there. And similarly, WC minus C for the characters. If you want to combine LC or CL, so that will be line number and character number. So these options are also there with the WC or word count. So we completed echo, we completed WC, redirectional operator. Any um, operation or any kind of command that you are having in the left hand side, the output of this command, if you want to save into some file, you can use the redirectional operator. So what you have to write? The command whose output you want to save, then the redirectional operator, and after that the name of the file in which you want to save the command. So if you press enter, the output of this ls will be saved into this file 1. It will not be echoed on the screen. Okay. Let me give an example to you. ls minus l. This output I want to save. So ls minus l, I am giving a redirectional operator and the name of the file is file 1. So now the output is not echoed on the screen. So if you check the content of the file 1, you get the output of ls minus l of then at that time what was the value of the ls minus l that was being saved inside it. Okay. Next is basic calculator. Basic calculator can be started with the command bc. Now you can calculate anything here like this. Say 5 divided by 3. It is giving 1 because it is taking 2 integers and it is dividing it and it is giving the result. But if you give 5 divided by 7.0, No, it is not coming. It is always coming like integers. So if the result you need to have like floating point, you have to change the scale. Let me write scale equal to 3. That means after the decimal point, I want 3 more digits. I'm repeating the same thing here. Whatever you would write. Okay. So after the decimal point, 3 digits I want to get. So I have set the scale to 3. Okay. If it is integer, the output will come like integer. If it is a floating point number, then it will be written as after the point 3 digits. 3 more digits will be coming. Now the scale you can change as per your choice. After that, suppose I want to do the binary arithmetic or the hexadecimal arithmetic or the octal arithmetic. So there also you can use the basic calculator. I base stands for the input base. Let me set it to 2. And now if I give 11 plus 10, the result is 5 because input base is 2. That means 11 is actually 3 and 10 is actually 2. So 3 plus 2 is 5 and the 5 is the output. If I want the output also in binary form, then I'll write O base. O base equal to 2. So if I repeat my operation here, 101 is the output and that is the output in binary. So all these kind of things can be possible using the basic calculator. We will be having a number of functionalities of the basic calculator during the shell programming also. To come out of the basic calculator, you should press Ctrl Z. If your machine, it is showing that uh, there is warranty issue and all, so that is not a problem. That may come with the basic calculator. That is not an issue. Okay. Now, after this, CPMP, CMPRM, another thing was there. Okay, pipe. Pipe is an operator using which you can pass the output of one operation into another. Like ls minus l, this is having an output. I am passing it to wc minus l. So basically it is showing that in the ls minus l output, 13 lines were there. If you check it, the ls minus l output, you can count the total number of lines present: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Total 13 lines are there, and those 13 lines, this output is been fed to the input of this word count for counting the number of lines, and that is giving us the resultant 13. So pipe is that. Pipe means one command's output is been passed as the input to the next level of the command. Okay, so you can have several levels of the pipes at present in the shell programming. You can have several levels of the pipes at a particular program. Okay, so two operators we have read. One is the pipe, another is the redirectional operator. CP. CP stands for copying. It is used for file copy. Let me copy file 1 into file 4. So if I check the content of file 2, it is this, and file 4, the same content. This is like copy paste. You can copy the file and you can paste it to some other directory also. In that case, the path should be mentioned with the file 4. MV. MV stands for move file 4 as file 5. Now, if I check with ls, there is no file 4 you can see, and the file 5 is present. So if you check the content of file 5, File 5 is same as file 4. So this is like a cut paste or renaming. If you do it in the same folder, it is kind of a renaming of a file. File 4 has been renamed as file 5. But if you do it in different folders, among different folders, then what will happen? From one folder, you are moving the file to another folder. That also will be happening here. RM, removing a file. RM file 5. Now you check the content with ls. File 5 is no more. So file 5 has been deleted. Now CMP. So let me check the content of file 1, file 2 and file 3. File 1 is this. File 2 is this. File 3 is this. Okay. CP file 2 to file 4. Okay. So now if I compare, just a minute. Can you see the presentation? So if we compare two same files, so it is not giving anything as there is no difference. But you compare between the different files, so it is showing that on the very first byte, on the first line, there are difference between file 2 and file 3. File 2 and file 3, yes, the first letter you can find is file 2 was I and file 3 is H. So obviously the difference starts from the beginning. So this is the CMP. Now, after all these shell commands, let us move to the filters. There are several kinds of filters. These filters will be required for us. Let me create a file. With a few numbers. Okay, so the content of the file I'm showing you. Now, sort command. Using the sort command, you can sort the file. Okay. So using the sort command, you can sort the file. I have applied the sort command to the file 4, and you can see the content has been rearranged. Is this file sorted? What do you think? Is this file sorted?
No, ma'am.
Somehow it is sorted. Don't you think so? This is basically a lexicographic sorting. Means what you find in the dictionary. Okay. String sorting has been done. By default, the sort is taking the string sorting. If you want a numeric sort, then you have to apply it with minus n. Now you can see the file is sorted numerically. If you want this file is to be sorted in the reverse direction, you can apply minus r. Again, the sorting has been done in lexicographical order. So, if you have to combine n and r together, that means this will be a numerically reversed order sorting. By default, the order will be the ascending and reverse order is the descending. Okay, so this is sorting. But if we still check the content of the file 4, it has not been modified. So sorting is giving you the output only on the screen, and if you need to save it, you have to use the redirectional operator and you have to use another file name so that it could be saved on that file. Okay, so sort is a filter. Apart from the sort filter, some other filter is there. Suppose I want to get the first 3 lines printed of this file 4. So I can use head command. Head -3 file 4. It will give you the first 3 lines out of the file 4. Similarly, there is a command called tail command. Tail -3 is the last 3 lines. Both head and tail will not hamper anything in the source file. They both are filters. Okay. Now, if I tell you that you have to print the third largest number present in the file, how can you do that? If your task is to print the third largest number present in this file, can you do it? Anything you can suggest? You have to print the third largest number present in this file using the means I have discussed over here. Anybody can suggest anything? So we can do sorting first, sorting in the reverse order of the numbers. So Rn with this file 4, this will give you the sorted list, the numerically sorted list. The output will be going to head -3. So it will cut the first three numbers, the largest three numbers out of the file. Among this, from the output of the head, we will be cutting the last number, the last line using this tail. So what we have 95, this is the third largest number. The other group could solve it of their own. I need not to tell them what you have to do. Can you see anything on the screen? Wait a minute, I have to probably restart my system. Okay, so we are back again. The next command we will be discussing is the grep command. Grep command is basically used to find a particular occurrence of a given uh, string in a file or in a target text. So let us check what is the content of file 2 here. Okay, in file 1 we are having some kind of a tabular structure. Suppose I am trying to get from here um, all those files which are having the name of file or which have been created in the month of October. So I can write here grep oct, then file 1. So it is showing us all those lines in which this oct was coming. Okay, so it is basically finding all those rows of data where the occurrence of the particular letter is there. Now instead of writing oct, if I would have written this small o oct, nothing was coming because it is not matching the case. Now if you need to have the case insensitive searching, so the option you should use -i. You can see with grep -i, again you are finding all those lines where this oct is present and the search is case insensitive. Here, if I write -v, so it is a negative grep, or where the line is matching. These things, those lines will not be given. It will given except those lines, all other lines. Now, as this small o oct is not present throughout, so it is giving the entire file present over here. Now, instead of oct, if I write here JUL, so it is giving all those lines except where this jul was written. Okay, where it is finding jul, it is not showing. Now, if we need case insensitive negative grep, that also could be possible. So in the earlier output, you can see small JUL was there. Now in new output, that thing is also removed as it is now case insensitive. The similar way, this oct, if we apply it with the case insensitivity, so this is also removing the oct which are present like that. Now, suppose we want to get those files which are created in the month of July. In the month of July, which files were created, that we want to get. So can we write here where I get Jul, those files? But you can see there is another file here. A file is there which is named as Jul. So that file is also shown. That file was created in the month of October. But that file we don't want. But that is also being shown. Now, if we do this searching with case insensitivity, still that is not a solution for us. So what we can do? You can see if JUL is a month, it is mentioned as a month. Every data which is mentioned as a month, prior to that there is a space, prior to that there is a number. And after this there is a space, after that there is a number. So this pattern it is following. But if it is the name of a file, prior to this a space and prior to that a number is there, but after this there is no space or number given. So if you can mention this kind of feature, if you can mention this kind of uh, representation of the data, then you can find easily which files are being created in the month of July. So in that case, what you have to do, grep July. After that, we want to have a space, and then within third bracket, I am mentioning a range of 0 to 9. Within this range, any letter will be picked and that will be put over here. So this type of thing is called the regular expression. You can see you are only finding those lines where after Jul there is a space and after that there is a number. Only those files you can see. You cannot see any file where the file name is Jul, because where the file name is Jul, after that this kind of features are not present. So this is called the regular expression. Okay. In your machine, you may find that the regular expression is not taking the single quote. So do it accordingly. Within the third bracket, whatever you are mentioning, it will take any of the letter from the mentioned range and it will be replacing it over there. Okay. So this is what we get as a regular expression. Now, if you have to print all the files present in the present directory, which are ordinary files. So for that, what you can do, see ls minus l. If you do that, ls minus l, the output is showing. If it is starting with small d, that means it is a directory. If it is starting with a hyphen, that means it is a normal file. So if you have to find the ordinary files, so ls minus l output, that you will send to grep as input, and you will find all those lines which are starting with is denoted by cap sign, starting with hyphen. So here you go, all the files are listed which are starting with hyphen. Instead of hyphen, if you give d, all the files which are starting with d. So these are the different options we have for the grep. The next command we will be discussing here is the tr or translate. So ls minus l output, I am fetching this to the translate tr command, and here I am mentioning the first range, that is A to Z, capital A to Z, and the second range I am mentioning here, it is the small a to Z. That means I want to convert all the capital letters into small letters. Wherever it will get a capital letters, that will be converted into small letters. Both the range is having the same number of data, so there will be no mismatch. You can see there is no capital letter present in throughout the file. It has been changed with a small letter. So that is the tr command, translate. It is also having many a use. So instead of putting both regular expressions, if you give tr minus d stands for delete the capital letter range, you can see all the capital letters have been removed. Okay, tr minus d stands for delete. All the capital letters are deleted. Here, if you write instead of d, cd, so that will be the complementary delete. If you do so, it is only keeping the capital letters. All the small letters and the special characters and the numbers have been deleted. Suppose you want the capital letters and also space. And also space. So you mention it like this. So within the regular expression, what are following, those will be remaining same and the others will be deleted. If you use it with D, So the space and the capital letters are deleted, the small letters, special characters, and the numbers are present. So this is the way how TR could be used. There is another use of TR, that is, if you want to replace the repetitive occurrence of a data with a single occurrence, there you can use this TR. Now, if you see the output of ls minus L, it is having some, on some of the locations, it is basically having a proper tabular representation, and to maintain the proper tabular representation, a few gaps are being padded between the two data fields. So obviously the space you are having here, that is not comparable with the space you have here. Now if we are trying to remove these spaces and we want to replace them with a single space, so for that TR can help. So that will be TR minus S, string squeeze the spaces. In this case, it is replacing the repetitive spaces with a single space. Okay, so these are the different utility of the TR command. And lastly, we have the cut command. In grep, head, tail, we have segregated several rows of the data from the file. Using the cut, you can segregate different fields from a table. Now, for example, we have a table here that is the output of our ls minus L. Now, from the ls minus L, suppose I want to print the very first characters and then the permission mode of the group, that means 1, then 2, 3, 4, 5, 6, 7, and the 12th characters. So for that, what you will be doing, ls minus L, the output will go to cut. I'm using here pipe to give the input. You can use a specific file as input as well. So cut minus C means cutting the columns of the characters. I want the first character. You can see all the first characters are segregated and shown. If we want, we can mention the range like D, then 1, then 2, 3, 4, then 5, 6, 7. So 5 to 7. Then I want the 12th character as well. Okay. So it is showing us the desired characters as cut column wise from the table or from the file. It might not be a table, it might be a normal file. You can cut the different characters from specific locations in this way. And then we are having how can you cut a specific field from a file. Suppose this ls minus L, here we have a number of columns. Suppose you want to show the permission mode of a file and the modification date and time. So it is going to be first column, second, third, fourth, and fifth you are going to skip, sixth, seventh, eighth, and ninth column. See, these columns you want to show. So that cut is going to be field wise cut. And here you have to define which character you are taking as a delimiter. So that should be written in this way. Cut minus D is the definition of the delimiter. Here we are taking delimiter is the space and minus F is the field. Suppose I want the first field, the second, third, fourth, and fifth we don't want, sixth, seventh, eighth, and ninth we want. So 6 to 9. But it is not showing us the data properly. The first field is okay, but the second onwards, the data is jumbled up. Why? Because there are repetitive spaces available. After each space, it is counting one field. So obviously, the fields are mismatching here. What else can we do? We can modify this ls minus l through this tr minus s. The repetitive space should be removed with a single space, and then we are applying the cut. So now you can see the output is having the perfect data as we desired for. Okay, so these are all about the filters, different filters and shell commands that we are going to use in the further shell programming area. I'm stopping it here today. Answer to the roll call, and one document you will be preparing according to the specification I gave you, and you will be uploading it to the corresponding link that also will be giving afterwards. Roll number 46,
Present, ma'am.
49,
Yes, ma'am. Present.
50, 51,
Present, ma'am.
52,
Present, ma'am.
55,
Present, ma'am.
56,
Present, ma'am.
57,
Yes, ma'am.
58,
Present, ma'am.
59,
Present, ma'am.
60,
Present, ma'am.
61,
Present, ma'am.
62,
Present, ma'am.
63, 64,
Yes, ma'am.
65,
Present, ma'am.
66,
Present, ma'am.
67,
Present, ma'am.
71,
Present, ma'am.
72,
Ma'am.
73,
Present, ma'am.
74, 75, 76,
Present, ma'am.
Ma'am, 75 present.
Ma'am,
77,
76.
Yes, ma'am.
77,
77.
78,
Present, ma'am.
79,
Present, ma'am.
80,
Yes, ma'am.
81,
Yes, ma'am.
82,
Yes, ma'am.
83,
Present, ma'am.
84,
Present, ma'am.
85,
Present, ma'am.
86,
Yes, ma'am.
87, 88.
Present, ma'am.
Okay, you may leave now.
Thank you, ma'am.
Thank you, ma'am.